bodies.
Twinkle, twinkle, little star, how I wonder what you are.
If you're out at night, it can be a little bit threatening if you're out in the dark and feeling a little nervous and unsure, but up there's Orion, there's an old friend. Some things are right, some things don't change.
Stars don't seem to change much during our lifetime, it's true, but stars do have a life cycle of their own. Look a little more closely at Orion. Under the three stars, the belt, there's the sword. You can see all this with the naked eye. But look at the sword through a telescope, and there's one of the most beautiful sights in the sky, the Orion Nebula. If you've ever wondered where stars come from, the answer is places like this. This nebula is a vast stellar nursery. This is how stars have been forming since the beginning of the universe. At the beginning, just after the Big Bang, there was just empty space with occasional clouds of gas. These were mostly hydrogen, the lightest element. In the bigger clouds, gravity pulls the gas together into clumps. If the clump is big enough, a nuclear reaction starts, and a star is born. Stars are forming all the time, and even some well-known stars in the sky are quite new. To the right of Orion, the Seven Sisters, or Pleiades. Sharp eyes can normally pick out only 6 stars, but a telescope shows there are hundreds. This is another stellar nursery. The Pleiades are only 60 million years old. If you'd been a dinosaur, you wouldn't have seen them. The dinosaurs died out 65 million years ago. The people who first catalogued the stars were the great Muslim astronomers of the 11th and 12th centuries, long before telescopes were invented, so many stars still have Arabic names. Al-Qaid, which means chief of the mourners, Mizar, Alioth, the white of the eye or intensely bright, Megrez, Fekdar, Merak, Dubhe. Even to the naked eye, the stars don't all look the same.
One night I went for a walk by the sea along the empty shore. In the blue depths, the stars were sparkling, greenish, yellow, white, rose, brighter, flashing more like jewels than they do at home, even in Paris. Opals, you might call them, emeralds, lapis, rubies, sapphires.
What do the colors mean? We can't all paint pictures like Van Gogh, but there's another way to capture images of the stars, so we can find out a bit more about them. In deepest Lincolnshire, I went to meet a man who's a sales assistant during the day, but whose real passion is photographing the stars. So, Paul, here we are standing in your front garden. Now tell me, why is it that here is such a good location for the budding astrophotographer?
Well, for one, we've got no street lights around us to cause problems at night with their glow. And secondly, we've got a good horizon around me. We see in the southeast, I've got a few trees blocking the southeast, but that's not too much of a problem. It's the south we really want, and say we've got a good view of that.
Right, now tell me, why is it that the southern horizon is particularly good?
Well, everything rises in the east and sets in the west, but they reach the highest point in the south. So therefore, they're at their best position to actually observe them, and therefore photograph them as well.
Right. So, Paul, I know you like to keep things simple, and you're going to show me just how simple it is to start off taking photographs of stars. So what do we have here?
Well, this is a very basic camera, which you can get second-hand, costs you about £20. So it's a nice, cheap, simple camera to get started with in astrophotography. You need a B setting on the speed setting for the camera. That allows you to take long exposures. A cable release helps because then you don't vibrate the camera as well when you're taking the photograph, and a tripod for rigidity as well.
This is a fairly standard lens, is it?
This is a very standard lens, that's correct. It's a 50mm lens, but that's standard lens that you get with most cameras.
And that's all you need, now you're ready to go?
That's all you need.
Okay, so you just you look through the camera, line up on a certain part of the sky you want to take a photograph of. And how long an exposure are we talking about?
About 20 to 30 seconds. That's enough to record the brightest stars in the constellation.
Maybe you'd like to demonstrate them. Give us a
Okay.
20-second exposure.
Right, well, we'll wind on ready for the exposure. Just check we're on the B setting. We've got the camera lens off. And then with the cable release, we just press in. Now we can count the seconds, or you can watch it on your watch. And then when the exposure itself is over, you just flick the cable release like so, and the photograph's taken. And that's it. That's all there is to it.
Great. See, it's easy, isn't it? Well, this is terrific, Paul, and obviously this is a picture of our old friend, the plough. Tell us a bit more about this photograph.
And this is one of the advantages of using a 50mm lens, because you can capture the whole constellation. We have the whole of the tail there, and then the bowl of the saucepan as such. So it's the plough or saucepan to many people.
Mm-hmm. You can see the double star very clearly there.
Yes, Mizar and Alcor. Mizar is the brighter star of the two. It can be seen with the naked eye, and is a good naked eye test for your eyes.
Yeah, better than going to the opticians, huh?
Yes, cheaper as well. Now I can show you the effect of trailing.
Yes.
And as you can see here, they've trailed quite a lot, because you're really showing the motion of the Earth, and the axis of the Earth points to one particular star, Polaris.
Mm-hmm.
So everything appears to revolve around Polaris. This is about 8 minutes long with the exposure on slower film.
Ah, yes.
Now that's Orion.
Right.
The bright orange star is Betelgeuse, seen there.
With the belt.
Yes,
Yeah.
that's
And
correct.
the sword.
And the sword is there, that's right. Again, a standard lens, a 50mm lens, is the one I use for this particular photograph.
Terrific.
Now I can do something special with Orion in this picture here.
Oh, yes.
And what I've done here is I've actually photographed Orion, like I showed you earlier, 30-second exposure. So this is the initial picture with the little tiny lines, the stars trailed. But to help to show the star colours, I then put the lens cap on and allowed the constellation to drift slightly against the picture. Then I took the lens cap off and slightly defocused the lens. So you've got these slightly broader patches of light.
Yeah.
And it shows the colours of the stars off far better. Now, colour equals temperature. So what we find is the white stars are very hot, and they have a temperature of about 20,000 degrees or more, so they're extremely hot. So they look white or bluey white. Whereas if we go to the other extreme, to the other side of the constellation, we'll have, say, Betelgeuse, which is an orange star. Now that's a cool star, so its temperature is between 3,000 and 4,000 degrees. So it looks orange to the eye and to the camera. Now the sun, if we could see it on this picture at that sort of distance, then it would appear yellow, because it's got a temperature of 6,000 degrees, so it's midway between the two. So you've got white is hot, red and orange is cool, and say the sun's in between at sort of yellow. So just by taking a simple photograph like this, you can show something fundamental about the stars in the night sky. You can immediately tell which are the coolest and which are the hottest.
Better and better.
Now this is what I call a pretty.
Yes. A very good picture for your estate agent.
I think it would be a very good advert for the house and surroundings. Yeah.
Now, obviously, this is not something that happens every night, so tell us about this.
Well, this is an aurora back in March 1991, and in fact moonlight helped to fill in the view of the house. The moonlight lit the house for us, giving us the picture of the house, and then the aurora in the background, with the stars trailed.
Interesting you should bring up the moon, because the moon really is the enemy, isn't it, of the astrophotographer. If there's moonlight, you obviously can't get the pictures you really want.
That's correct. It's almost like light pollution at its extreme, because when the moon's up, we can't take the sort of photographs I've just shown you, because the moonlight washes out the fainter background stars.
Twinkle, twinkle, little star, how I wonder where you are. If the moon makes it hard to see the stars, the lights from modern cities are far worse. Astronomers often complain about light pollution. From a dark site, this is what you see if you look towards Orion. But view the sky from almost any city, and you hardly see a thing.
When I now look around the city and I still see new schemes that are being installed with what I would call the cheap and cheerful, with, in my view, not really enough care for the customer, and I do get a little bit concerned that perhaps we ought to be installing better quality lighting schemes.
Up until quite recently, Jerry Davis was the lighting engineer responsible for the city of Portsmouth. This is one of the most densely populated cities in the country. Lighting engineers are often seen as the bad guys by astronomers, but there's more to it than just spoiling the view for stargazers.
When I see satellite pictures taken of the amount of light that is shining upwards and perhaps in a lot of cases wasted, then I'm quite horrified by it. And I'm sure that if more people saw this type of thing, then perhaps they might start to do something about it. The older type of lantern, which has been installed for a good number of years now, is reaching the end of its useful life, and there is no doubt that there are figures that people have quoted. Up to 30% of the light goes directly into the sky.
Unfortunately, there is no guarantee that modern lights are any better.
This example of a retail car park on the grounds of wastefulness gets a score of about 9 out of 10, because it's extremely wasteful. As can be seen from the luminaires, it's a spherical prismatic luminaire that all that tends to do is to splatter the light almost 360 degrees around the sphere. I would have guessed that there is at least 50% of this is going upwards, serving no useful purpose. A complete waste of energy. The lighting in this supermarket car park is special because Portsmouth City Council, as a condition of their planning application, insisted that instead of their normal standard, which would have directed more light skyward, that a special type of lantern which directs all the light downwards was used.
So there are ways of directing the light downwards. In 1990, the British Astronomical Association set up the Campaign for Dark Skies, but too few people have seen the light.
Astronomers have not had a very great impact on lighting engineers because their campaign really has been treated with a little too much contempt, in my view, when perhaps lighting engineers should sympathise a little. After all, it seems such a pity that this light from the stars travels all these millions of miles to disappear in the last 4 or 5 miles. Seems such a shame.
The glaring lights of the city tend to drown out the light of the stars, and it's very easy to forget just how impressive a sight this would have been to our ancestors. Even now, at a really dark sight, the stars seem to fill the sky from horizon to horizon. And spread across the sky, something else you don't see in the cities, the Milky Way. Made up of hundreds of thousands of stars, the Milky Way is our own galaxy. All the stars that we can see in the sky are part of this galaxy. Because we are looking at it from within, it looks like a straight line. But if we were far enough away, we would see it for what it really is. Our sun is pretty much out in the galactic suburbs. This has to be the best place to start astronomy, learning your way around the night sky. You don't need a telescope. Every star you can see was catalogued thousands of years ago, just with the naked eye. Here's a familiar constellation, Ursa Major, the Great Bear. Part of it is the well-known shape of the Plough, or Big Dipper if you're American. The last two stars of the Plough, Merak and Dubhe, form a useful pointer towards this star, the Pole Star, Polaris. Astronomers call this star hopping, and it's a good way of finding your way around the night sky. This instrument, a planisphere, shows the star constellations, but you have to set it for the date and the time, say 8 p.m. on the 5th of March, and then the stars we see in the window are the ones in the sky at that particular time. The constellation up there is Auriga, the charioteer, and here it is on the planisphere. I would expect to see near it the constellation Gemini with its two bright stars, Castor and Pollux. And there they are in the night sky. The planisphere needs adjusting for two reasons. We have to set the time because the Earth is spinning on its axis, and we have to set the date because the Earth is moving around the Sun. Our orrery just shows the Sun, the Earth, and the Moon, but it does include the stars as well. As the Earth spins on its axis once every 24 hours, this direction, towards the Sun, will be daytime, and we won't see those stars. It's the stars around here, away from the Sun, that will appear in the night sky. Over thousands of years, we've come to associate groups of stars with particular patterns or constellations. There are 88 constellations in all, but not all of them are visible from the northern hemisphere. Here in the autumn night sky, we see the constellation of Perseus, and below it, Aries, the ram, one of the constellations that make up the signs of the zodiac. In the spring, the Earth is here, and in the night sky we'll see the constellations of Gemini, the twins, and later on, Leo. Now, as the Earth moves around, when we look in the summer night sky, we see constellations like Libra. Another 3 months, and in the autumn, we'll begin to see Capricorn. Now that it's autumn, the spring constellations like Gemini are there in the daytime sky, so they're not normally visible. But we found a way for you to see stars even in the daytime.
Well, I've got 5 major telescopes in the different domes here, but the one that we're going to use today is the biggest one to give us the best light grasp. Well, what we're hoping to show you is Castor and Pollux, which are the 2 brightest stars in the constellation of Gemini in the daytime sky.
I just found Pollux. I'm centering it up in the field of view of the little telescope here. And now a bit of look. Come down and be able to see it on the screen. We have a television camera attached to the back of the main telescope, and that's sending an image down here.
Now, Gemini is a constellation you'd normally see in the night sky around, what, springtime?
Yes, it's really best to January, February, March time. Really nicely placed then in the night sky. But of course we're seeing the thing in the daytime sky in the autumn instead of the nighttime sky in the spring.
There we go. Oh, that's quite nice.
There we are, and that's Pollux, which is the brighter of the two. Now that particular star, Pollux, is about 33 light years away. So the light that's falling on the screen now has been travelling through space for 33 years to reach us.
Now, is looking at stars in the daytime just a good excuse for astronomers not to have to spend all night in the observatory, or is there?
Well, I think it's really just to demonstrate that the stars are still there. We don't normally do our observations of stars in daytime because we can do them far better at night, and we just have to put up with the cold and the unsociable hour.
And of course, a lot of people, I suppose, do believe that the stars somehow go in during the day and then they come out at night, but not actually there. But of course, this shows they very definitely are.
Absolutely.
Okay, well, maybe we can move across, have a look at Castor.
Have a look at Castor. Should be roughly in the right place.
Okay. Well, it is considerably fainter, isn't it?
Yes, it's certainly fainter. The other thing about it is that it's actually a double star, a binary as we call it. It's two stars that revolve around each other. You can just see the fainter one on the left-hand side there. And these two stars are about 40 times as far from each other as we are from the sun.
Really? Now, observing stars in the daytime is not something you can do all day long, so do you have to pick your time very particularly?
Well, it really requires a very clear blue sky and no haze or cloud around, because even a little haze or thin cloud is going to make it quite impossible. So the conditions have got to be right, and that's very often the way earlier in the morning rather than later in the day.
As you can see, it's not always clear that the two stars are double because of the atmospheric twinkling, which is making the images shimmer around an awful lot. And this is an unfortunate characteristic of all astronomical observing. Produces a nice effect, the twinkling to the eye, but for observing like this, it really makes it much more difficult.
And this is really due to the fact that the light from those stars is having to come right down through our atmosphere, and the air is unsteady and turbulent. Same sort of thing as you sometimes see on a hot day, where hot air is rising over a roadway and it makes things shimmer and shake. Well, our atmosphere is doing that to the stars as well.
Have you ever wondered about your star sign? If we could always see the stars in the daytime, it would be obvious that at any one time the sun would be in front of one of the constellations. We talk of the sun being in a particular constellation. This is the stuff that keeps astrologers in business. Here the sun is in Aries, but some weeks later, as the Earth moves around the sun appears to move into Taurus, and then on into Gemini. Normally, of course, you can't see which constellation the sun is in. People just have to take the astrologer's word for it, which star sign the sun was in on the day they were born.
In 1991, I had an absolutely wonderful birthday present. There was a total solar eclipse. I'm a Cancer, and my birthday is in July. What actually happened in the eclipse, the moon started to go across the sun, and it got darker and darker until the stars came out. And guess what? The sun wasn't actually in Cancer at all. It was really in the next door constellation, Gemini.
If Jacqueline had had her birthday 2,000 years ago and there'd been a handy solar eclipse, she would have found the sun in the right constellation. But the Earth's tilt has a slight wobble. The point where the Earth is tilted exactly towards the sun is by definition the summer solstice, the longest day.
When the Earth is tilted exactly towards the sun, it's the point in the year when we get the longest day, which has to be June the 21st, the summer solstice. 2,000 years ago, the summer solstice would have happened when the Earth was here. The sun would have been in Gemini. But the Earth's tilt has wobbled since then, and now when the Earth points towards the sun, it's here, and the sun is in Taurus.
This is still by definition the summer solstice, and every 2,000 years or so the sun slips another sign, and in around 24,000 years it'll be back to where it started. So if your horoscope doesn't seem to have got it quite right, maybe you should try reading the sign before yours.
Twinkle, twinkle, little star, how I wonder just how old you are. Stars are not forever. Just as they can be born, so they can die. Some small stars, like our sun, can just run out of fuel and cool down. But if a star is big enough, it goes with more of a bang than a whimper. The universe started with mostly hydrogen, the lightest element of all. The nuclear reaction inside a star converts hydrogen into other, more useful things. Take the star which astronomers rather imaginatively called SK-69202. The star was born 20 million years ago, pretty young by star standards. It was fueled by hydrogen for 15 million years or so. Then, when all the hydrogen had been turned into helium, the star began to use the helium instead. The helium stage started when the first ape men were appearing on the Earth. A million years later, the nuclear reaction in SK-69202 had turned the helium into carbon. That was around the time of Stonehenge and the pyramids. The carbon stage lasted for several thousand years, the whole of human history. But by 1980, the star was turning carbon into neon and oxygen. Then, on about February the 20th, 1987, it was a Friday, our star was running on silicon. This stage lasted just a few days and produced the iron core. That's as far as nuclear fusion can go. There was now nothing left for the star to use, and the core suddenly began to collapse on itself. On Monday, February the 23rd, 1987, at 7:35 in the morning, star SK-69202 ceased to exist. Observers on Earth took this photograph. It was the largest, the nearest, and the brightest supernova seen for 400 years. At that moment, when a star dies and explodes as a supernova, the tremendous energy involved is sufficient to produce all the heavier elements: copper, tin, lead, silver. And all the elements that have been made within that star are suddenly scattered out into space.
That supernova was of great interest to astronomers, but there were others that affect all of us much more. We believe that our universe was formed about 15 billion years ago, and our own solar system was formed about 5 billion years ago. And somewhere in between those events, there must have been at least one star that exploded as a supernova in our part of the universe. The elements that were produced in a giant example of recycling went into the formation of our solar system, the Earth, and all the other planets. So our whole world, everything we see around us, our bodies even, are actually made of the remnants of old stars. We are truly made of stardust. We put together an astronomy project pack, which will help to get you started if you'd like to find out more about the night sky. If you'd like a pack, please send a cheque or postal order for £9.99 made out to BBC Education to this address. Astronomy Pack, P.O. Box 7, London W3 6XJ.
Looking to the skies again at 12:30 tonight, Patrick Moore examines some newly discovered worlds in our solar system in the sky at